Hello. Welcome everyone to day 2. I love that countdown.
Hello. Welcome everyone to day.
Hey Marino, I think you still have the
It's me.
background.
It was me.
It was you.
Yeah.
But yeah, day 2. Today we'll talk about traffic management. Yesterday we did installation, and today it's all about traffic, how to bring traffic in, how to manage it within your mesh. And Alessandro, the floor is yours.
All right. Hey, welcome everybody. We had great feedback from yesterday, right? So we had a bunch of people, very famous names, some fellow ambassadors, and people from the Istio community. So let's see if we can keep it up for another. What is 4 days left, 3 days left. So let's see if there is still interest. We welcome your feedback, right? So the YouTube chat stays on only during the duration of the stream. We do have, of course, our own solo Slack. So it's still solo.slack.io. I'm not sure, but I will drop the link. We also have, of course, the Istio Slack. You can find us somewhere and just give us some feedback. If you like it, if you maybe need another week or maybe some deep dive. Maybe we should have Ask Me Anything session maybe next week or sometime, so we can gather the feedback. But yeah, so the idea of this Mesh Week, if you haven't been yesterday around, we want to help people getting certified with the newly released Istio Certified Associate certification. So it's not a replacement for studying for yourself. Just we kind of learn in public, or we already know a few things, right? So I mean, Peter and Marino for sure, they know quite a lot of Istio in and out. Me, I'm trying. I mean, of course, but the idea is that we do it together, and then we all get there together. So I hope to see in November, and whenever we can start scheduling the exam, bunch of people posting that they passed the exam, maybe in small part thanks to this this learning occasion. So we'll love to help you out. So come over YouTube, Slack, ask us questions. So these are really complicated topics, of course, and the more we get through the week, the more complicated it gets. But we do want to help everybody to be there. So today we are day 2, of course. So let me see if I can share my screen. Let me share the whole screen, because this kind of things we yeah, is it going?
Yeah, let me add it to. Oh, you'll have to probably fix the font size.
Fix the font size.
Yeah, I mean we see your whole screen, so it's very hard to. Yeah, this looks better now.
Right.
This is
okay.
perfect.
So
yeah.
Session
I mean, perfect for me. Let someone on the stream who's actually watching on YouTube tell if it's.
I've got YouTube open and I see that it looks good.
All right. Awesome. So this straight from the exam, right? So this part. So yesterday we covered all the installation, which is part of the exam, of course. I mean, I suppose, like other hands-on exam of Linux Foundation, you through the browser you access this virtual machine, or maybe it's a Docker container, we don't really know, but I suppose it's a virtual machine, and then it's just plain supposedly Ubuntu. At least last time I checked, they tend to have all these exams on Ubuntu, and nothing is there. Probably maybe a cluster, a kind, or some sort of Kube ADM cluster is there, and then you gotta install Istio yourself, right? So, and then yesterday we cover all the topics about how to install Istio with Dell, with the operator. We talk about all this stuff, and then this is it was, I think, 17% of the exam, and this, I think, is the core. Now, some tips for the exam, right? So at least as far as I remember, like CKA, CKD, I think these are not different, right? So these are time limited exams. You don't have 5 hours, you don't have 4 hours. I suppose you have something around 2 hours. I don't know if it's already published, the amount of time you have, but CKA for sure, I think it was around 2 hours. So you are under a lot of pressure to finish. And every question you don't answer, it doesn't count. So you better answer something in some way. Try to do an educated guess. You can always come back to questions afterwards. So you can mark them to be reviewed. So just put some thoughts up in the question, answer, and then you can come back. Also, if it's like the other CKAs, questions are also have different weights, right? So fair, or maybe even says at the top of the question how much a specific question or problem, right? It's more than a question. These are problems, like because these are hands-on. So at least in the CKA, you, for example, have to create or modify some deployments, and then you should get the like the list of pods or sort of stuff, or this kind of stuff, and then you write it to a file, and then the automatic script that grades your exam will read this file and compare it to the acceptable answers, and then grade that particular problem. And the problems are graded and they have specific weights, so you should consider if it's, you have to make a very quick analysis cost benefit. So if it's a low weight question or problem and you are spending a lot of time on it, maybe it's not worth it. You just move on, go to the next question. Usually these questions are disjointed by each other. It's not like you need to finish them in order. You can start from the bottom.
You don't have to follow them, answer them in like. You can move across the exam, pick any question that you want, and start with any one that you want. But as you mentioned, this 40%, I think this is the weight these questions have in terms of like on the whole exam, right? So 40% of the score is going to be from the traffic management, right? So it's an important topic, I guess.
Yeah, so of course, like if you don't, one of the lower score, like 17%, I think installing. But in general, like you should get, you should be aware that the final score that should, I don't know, maybe 70% minimum or.
I mean, I don't know. I don't think I don't know. Do they publicize that for the other exams?
They
what the passing score is.
The threshold, the passing score, it's known. I think it's the 75, 80%. Okay. But in general, like, so this was even I published some articles on Medium back in the day. Really, time is of essence here, right? So focus on what you can do immediately. So get the low hanging fruit, and then you move through the exam. More agile, right? So once the easy part is done, you can focus on the hard part. Otherwise, you end up with less than ideal score because maybe there were questions that you could answer and you didn't because there was no time. So
basically, don't spend, like, if you're spending too much time on one question trying to figure it out, maybe it's time to leave it for the end and move on because there's a lot of questions.
Right. I don't know, but I recall the CKA and CKAD had, like, they would tell you how many points each question was worth on the exam, like while you're in the exam, so you can actually kind of keep a mental note of it. And so, like, if you're guaranteed like a certain amount of points, then the ones that you get stuck on, you could probably just overlook, right? And that's kind of how I treated it previously. I mean, I'll be honest, when I passed the CKAD, I think I passed it by 1 point. You needed like a 66 or 67, and I just got like 1 more point. So I was like, damn, okay. A pass is a pass. So
it's 60%. So it's not impossible to achieve. But keep in mind, this is an associate exam. So I mean, we don't read minds, but typically they do like associate level and then a bit more, I don't know, master, whatever, level later on. So this is kind of the basic stuff, at least in the mind of the whoever designed this certification. And there could be maybe later on they could release a more advanced Istio certification. But this is being an associate. See, also maybe because that's why it's only 60% you need to pass.
It does say 60. Yeah, you're right. And you have
and you got 2 hours.
Yeah.
So 2 hours, 60%. So of this curriculum, of this syllabus, see, the advanced scenario, although I suppose these are the hardest question you can get, right? So this is kind of arcane magic of connecting virtual machines to the mesh. It only accounts for 13%. It could also be that there are only a few questions about this. So maybe those 1-2 questions, they count for 66%. And then maybe it is worth to spend some time. But definitely it's something that we can discuss. And then we, I think this one free retry for for the exam.
I think you know what we should do, Alessandro? I think after this week we should have a separate episode where we talk about like tips for taking the exam. I personally haven't taken the exam or certs, but I know others who have, and I think it might be valuable to others to actually full 45 minutes or whatever it is, just talk about the actual, here are some tips, right, on how to navigate these exams. But
yeah, so because we've kind of we've done it, so we love for everybody that is here or listen to this to pass. So we try to give you all the tools you need. So traffic management, I think, is the bulk of the exam. It's also the bulk of the use cases of service mesh, of course. The other being security, and there's a specific section about securing workloads. But this is all about the Istio features around traffic management, routing, and also sort of interesting things you can do with the traffic within the service mesh, and what Istio offers you, what kind of objects and API you can use with Istio, from Istio to configure your traffic. So it's important to understand what you can do. A section is on configuring Sidecar injection. So we'll discuss what is the Sidecar object and what is the Sidecar injection. So not sure, we are not sure because we haven't seen the exam yet, but we'll give you all the information you need to understand how Sidecar containers works in Istio and how the Sidecar object affects the behavior of the service mesh globally on the cluster and of the service mesh in a specific namespace. And gateway resources, I'll talk a bit about this, of course. So this being probably developed maybe some time ago. The gateway resources are important, are the ways for to define the entry point of traffic and the in your cluster. But we'll talk about the difference between the gateway resource under the Istio API, and that's not part of the exam, but I would like to also talk about what is a gateway resource in the gateway API Kubernetes domain, so API, right? So we'll shed some light on the difference between the two ways of because one represents the old way, the one that is also in the exam, of course, and one represents the new way, and we need to know things before they become the de facto standard. It's quickly becoming, it's been adopted and discussed within the Kubernetes and the service mesh initiatives, how and when and why migrating away from the old way of doing ingress to the new way, which is the gateway API. we talk about ServiceEntry, which is how to connect external services, how to let's say control the egress traffic, and how to add entries to the internal service edges. So how to define workloads and endpoints from within your mesh that refer to an external service. So this is typically used for virtual machines, for make sure adding endpoints manually, so to say, of course, through CRDs and through native objects, but they are not auto-discovered by the service mesh. So you need it when you want to add to point your traffic to some specific place, and then what is a destination rule, how to use traffic policies, and in this part is traffic mirroring. So, and we'll talk about tomorrow, right? So the next session is indeed about all things like retries and fault injection. But today we'll just look at the traffic mirroring, which is really like an Envoy feature, just replicated within Istio, and we'll show how to do it. So most of this will be referring to a lot of the Istio documentation. So we'll refer a lot to the Istio documentation. So as of what cluster you need, of course, to learn, you don't need a cluster. I mean, you don't need a managed service. You don't need to pay anyone. Your laptop is enough. You just need any Mac or Linux or Windows machine. We use Kind a lot. Sol, of course, but in general, like, is one of the best way to learn. So you don't need much. I pushed this to the EP2 branch, and then we'll probably I'll open up pull request, but it's on a branch on our mesh week. But in general, like, it's something very simple. You just make it a bit bigger. So it's really as simple as create a cluster with Kind. So I had a cluster. I installed Istio, of course. Yesterday we saw it. So sure, there's millions ways to deploy Istio. One of the very convenient way is to install Istio-CTL. And that's what I did. I just followed this, and I'll add more stuff as we discuss it. But in general, this is how you create a cluster. And then, of course, you get these are running Kind cluster with full suite of Istio. So there is Istio-D, as you know. So Istio-D is the brain, the control plane. It controls everything, does the Sidecar injection, and so on. The demo profile installs the egress and ingress. So two pods running Envoy, specifically dedicated to for the ingress traffic and for the egress traffic. And then I also installed the gateway API, because never know. I mean, we might talk about it, but in general, like, I always like to install gateway APIs. Again, the CRD is being beta in the Kubernetes project. They are not installed by default, not even in AKA in managed service like EKS or IKS or GCP or GKE, and also Kind doesn't install these CRDs by default. So it's a simple command. It pulls the CRDs from the gateway API.
One thing I want to bring up here is the gate. There might be some confusion here, right? Gateway API is different than the gateway resource that's in Istio, right? Just want to make sure that people know that there's two different things here, right? Gateway API is the new, I'm gonna say, let's say, replacement, right, of the old Kubernetes ingress resource, whereas the gateway resource in Istio is a resource that allows you to configure a gateway.
Yeah,
an ingress gateway in Istio, right? So it's
the interesting thing and the best thing about the Istio documentation is that for most of the things you can do with Istio, for example, routing to an endpoint, right? So writing to a service, there is always the docs have this dual way, so you can select which way you want to go, and it's great because it also helps you really thinking, oh, this is the old way, right? So I'm way at some point. So I'm creating an object called gateway in Istio, and then I'm creating a HTTP route. I create a virtual service in Istio, which translates to a gateway API in gateway API. So it's the same Istio, it's the same control plane. Just because you refer in a different way, it creates different objects. So it does the same thing but a different way. So I mean,
I think well, I don't know. It's not. I would expect if this was part of the exam, they would probably call it out. I don't think it necessarily will be, but it's definitely good to know that there are two ways to do things, right?
I'm saying, I mean, we have discussion internally, but also in general, like, do I need to learn? Well, it's coming, and there's no way to stop progress, right? So there will be a point, could be a year from now, could be 2 years from now, ingress will be deprecated. I mean, it's like Thanos, right? So Thanos, the Marvel guy, right? So it's inevitable, right? So you can wish for not being deprecated, but that's the plan. And eventually we will be in a world where ingress will be
it's definitely something people should keep in mind, right? For sure. But
okay, so Sidecar injection, and that's you might have known already. Of course, like, there are ways we talk a lot about ambient, but this is not the case. So we really want to focus on what happens when a service that is onboarded on the service mesh, which means that it has the right label applied, and the Istio control plane recognizes that this service needs to be onboarded on the mesh. What happens then, right? So what is the old magic that happens within Istio, and is basically leveraging the mutating ambition controller, which is standard way for the API server Kubernetes to mutate, to add, sometimes remove, actually, but in this case, in the Istio webhook, in the injection webhook, which is running inside the Istio control plane, takes the request from your user. So you want to create a pod, you want to create a deployment which creates pods, but in general, like, whenever a pod is scheduled, that goes through a series of steps, right? Authentication, authorization, and so on. One critical step is the mutated admission controller. So if that manifest, that pod needs to be onboarded on the service mesh, then it goes through the injection webhook, and that the manifest is augmented, so to say, is modified by adding the Istio Sidecar.
Mm-hmm.
Actually, we have a great article on the Solo blog. Of course, there's a bunch of links in there, and I would like to point to slightly old, but still very valid, and it explains very well what happens when you want to when you onboard a service into service mesh. So, and the critical step is this labeling, right? So by simply labeling a namespace, you are telling the control plane of Istio, now everything that runs in this namespace, every object of kind pod that runs in the namespace needs to have the proxy injected into the pod. So of course, so the deployment stays the same. Of course, the replica set stays the same. It's the pod manifest they are being injected with two containers, the Istio init and Istio proxy. Istio init configures the IP tables in the pod, and Istio proxy is the actual proxy that hijacks all the traffic, and that does does the service mesh really happen? So,
Yeah.
this great article is in this slide, so you can look into it. What can we say about this? Of course, there are many ways. I don't know if this is also part of the exam, but if you have noticed this TOCTL command line, you can, yes, so there's the kube inject command that will help you. So this is this is a very common command, right? So you are basically creating, adding the sidecar through this TOCTL kube inject command, and then applying right away with the kubectl apply command. So kube inject emulates the Istio webbook, right? So it will show you, it will output the same manifest with the injected sidecar into it. So this is how you, let's say, modify an existing deployment. So a deployment is already running. You can take the YAML, the output, pass it through the kube inject because it accepts input on the standard in, and then reapply the resulting manifest right away. So this is what you can do when you want to see the effect, right? So for example,
While you're typing, I also want to mention there's a resource called Sidecar, and we're not sure, like in the certification and the exam, it says configuring Sidecar injection. There's the whole injection process, right, that Alessandro was talking about, but there's also a resource, a CRD in Istio called Sidecar, which you can use to basically configure how the Sidecar proxies, like configure inbound and outbound communication from the Sidecar proxies, right? So things you can do is you can configure different like egress and ingress sections and say, oh, only this configuration should be sent, only this, like this sidecar should be configured for only this ingress and for only that ingress. So I think it's more of a I would put it in advanced topics, to be completely honest, the sidecar resource, but it's another thing to be aware. There's the injection, but there's also this sidecar resource, and we're not like 100% sure what was that configuring sidecar injection section. What is it actually referring to, right? Which topic?
Yeah, we'll show it in a moment. So just so you just mentally prepare, and this is why we always advocate and we talk about sidecars are awesome, great, although there is some problem with them, which is they're a bit complicated, right? So the sidecar model of service mesh has been working all this time and pretty all right, but there is some mental load. So look, this is just a simple pod, and then when you look at the injected pod, right? So the pod the original container is still there somewhere, of course. The original container is here, right? And everything else is added. So this is why we always say, yes, sidecar containers are great, but we should move past that, beyond into the magic realm of ambient mesh. But so you know, this is what happens when the mutating webbook takes this manifest and adds what it needs for the service mesh to work. So if this is a service mesh onboarded service, then all this Istio init and Istio proxy containers run alongside. The Istio init is an init container, of course, so it runs, does its job, and then dies, or like a exit gracefully, and then the Istio proxy takes over the traffic because you got this magic capabilities where you can take over the network namespace. But so this is how service mesh works under the hood, right? So you don't see all this complexity unless you go and pick under the hood, but that's how it works, and that this is something you should get. So yes, indeed, we were wondering, like, because we are reverse engineering the exam in a way, right? So it says configuring Sidecar injection. So yes, we wanted to show this for sure. And then there is an object indeed called Sidecar. So this is a bit confusing for me for sure, and hopefully not for you. And after this, of course, so see even in the docs, there's a installing the Sidecar injection, and then there's a proper object called Sidecar. So what does it do, the Sidecar? It affects or controls the behavior of your Sidecar, as Peter said. So, and there are many ways to do this, right? So you can have a global Sidecar object. It's global only because exists in the root namespace of the service mesh. So there is a special namespace in every installation of Istio, which is where the control plane lives. And normally, at least, okay, in my case, for example, of course, there's a Istio system. So this is the root namespace in Istio parlance. So if you create a Sidecar object in that namespace, like in the example from the documentation, this affects all Sidecars everywhere. So the whole cluster gets this configuration. If you create instead that Sidecar is a namespace scoped resource, right? So it's exists in a namespace but because it's in the root namespace, it will affect the whole cluster. Otherwise, it will affect only the namespace where this Sidecar exists, right? So, and it's a pretty complicated, or at least it's an interesting resource, right? So you got a lot of stuff that you can use the Sidecar object to manipulate. For example, the outbound traffic policy. So for example, the outbound traffic policy mode influence the way the Sidecar talks to external service. So registry only, you restrict the Sidecar, so the application, to talk only to other services in the mesh. So anything else is hidden or doesn't work. I mean, so you effectively restricting the outbound traffic to service defined in the service registry. Not, of course, and we'll see why ServiceEntry is important here, because you can use registry only, block all outbound traffic, and then allow only the traffic to specific service outside the mesh by using ServiceEntry.
Yeah.
Or you can, and this is the default, right?
Yeah. Yeah. So by default, it's allow any. But one thing to bring up here that's important is this is not a security boundary, right? Like if you set the outbound traffic policy mode to registry only, yes, mesh services within the mesh that are trying to call to the services that are outside of the mesh, right? The Envoy will automatically drop the connection, right? However, that doesn't mean that if I create a pod in the same cluster, it's not part of the mesh, I'll be able to access it out, right? It's not a security policy, right? It's just a way of, in the Envoy configuration, of sending the traffic to black hole cluster versus pass-through cluster, right? So if you've ever seen an Istio in the logs, black hole cluster or pass-through cluster, if allow any is set, it's typically a pass-through cluster because it's just going to pass it through. If it's black hole, you have registry only, and you're trying to access something that's not part of the mesh, right? But yeah, the default is allow any. It used to be registry only. I remember when it was registry only, and then it was very, it wasn't good for like user experience, right? Because people would install the mesh and then they're like, why can I talk? Nothing works, right?
Yeah.
But yeah.
And in this case, of course, when you say cluster, you mean Envoy cluster, right?
It's Envoy cluster. Yeah. Envoy cluster configuration in the Envoy cluster.
Which is a collection of endpoints, right? So it's just a way for Envoy to define where to send traffic. Right?
Yeah.
So, and then, so also important, the workload selector, of course. So not only the Sidecar is namespace scoped, but you can also further restrict where to what this Sidecar resource applies to with a workload selector. And there can only be, and this is somewhere in this doc, there can only be one Sidecar.
One default one per namespace.
Yeah.
I think.
Yes, a Sidecar that doesn't have any workload selector, which means applies to all workloads in the namespace.
Yeah,
there can only be one, because otherwise it's confusing, because then you use the same Sidecar object to define, right? So it's an interesting
it's a very, maybe we will revisit this on a last day just a little bit, because it is, I think it's more advanced resource if you think about it, right? Because it requires you to actually know, it requires you to know what you're doing in a way, to be able to like configure it the way, and actually to be able to actually get to a scenario where you will need to configure this, if that makes sense, right? But yeah, there's 3 levels, right? Like global namespace and workload level that you can set it.
The way I learn about Sidecar, the resource Sidecar, is that when you scale and your service mesh, your cluster becomes sizable, right? So hundreds of services. You have to understand this. So every Sidecar in the cluster gets the same configuration, but you can use the Sidecar resource to limit what a Sidecar in a namespace see, and also consequently the amount of configuration that proxy will get. And this will help a lot with the
that's I think that's the one of the very, very popular use cases for this resource, because if anyone has seen Envoy configuration before, you know it can get very sizable, and then if you multiply that by hundreds or thousands of services and multiple namespaces and big clusters, the control plane will be sending that configuration about everything to all the services, all the proxies in the cluster, right? So with the Sidecar, you can say, hey, no, the services in this namespace only have to care about the services in the same namespace. They don't need configuration of services from the other 99 namespaces, right? So
so it's important. So you will find it a lot, because it will I mean, I would say best practice of Istio is to have a Sidecar configuration in a namespace, so you can restrict the amount of configuration. So that's something we suggest to do. So we talk about it: Sidecar injection, Sidecar resources, not the same thing. You should understand how to do both, of course. But definitely have a look at the blog, right? So moving on, I don't have a slide about gateway resources, but we'll go through of course, the documentation. So a gateway is, I have this slide here, of course, a gateway. So these are resources, the three factor of the Istio routing resources are, of course, like the gateway, the VirtualService, and the DestinationRule. So the gateway is the entry point of your traffic, right? So it affects how traffic that is incoming in your cluster will be recognized, right? So there's a host over there. Let's see, a simple gateway resource, of course. So there is a number of hosts in there. Can be one, can be an array of hosts. So this gateway will be applied to all traffic that has the header host matching these two DNS names. So if you send traffic to the ingress that doesn't have these host names in the headers, the traffic will be at least this particular resource will not apply. So a gateway is definitely, and I think it says here, is a load balancer open at the edge of the mesh, which most of the time, and in our cluster, of course, we have this, of course, this beautiful ingress gateway, again, Envoy proxy, configured through these resources. So whenever you send traffic to this, then it will perform some matching on the host, and then if one of those matches, then will be sent to the virtual service, which explains what to do, the rules when there's a NOS matching. So this is how it works, and the destination rule is more like just a way for Istio to define who is what, right? So destination rules simply assign a subset like V1 to a series of services, Kubernetes services, that match a specific label, right? So and you can also use destination rule to do more interesting stuff. I think things like traffic mirroring is in the destination rule, if I'm correct. But
no, it's virtual service. Yeah, but destination rule. Yeah, the destination rule is typically you can configure the destination configuration. No, the traffic policy, right? The load balancer policy, right? On how the traffic actually gets to the destination, right? You can do circuit breakers there. You can specify the
fault injection.
No, that's virtual service as well. Destination rule is, so virtual service is going to point to a host, right? To an actual like service matched by the host. And then destination rule is stuff that gets applied once the traffic has been routed to that destination.
Yes.
Right. Yeah. So
this is the sequence, right? So first gateway, host matching, everything checks out, then virtual service. And when there's a match on the subset, it goes to the destination rule, right?
Yeah. So it's basically, so gateway is, as you mentioned, right? You define the host, you define the port, right? The port and the host combination is what you're basically saying. Hey, that pod that you showed, the ingress gateway pod, right? With the gateway resource, you're saying, hey, Istio ingress gateway, listen for this host on this port, right?
Mm-hmm.
That's what you're saying there. And there's also, like, if you list the services, there's an Istio ingress gateway service, which is of type load balancer, right? And that's the actual like IP address, right? Where you would set, this guy, right?
Yeah.
You have it metal LB, yeah, but that's the actual load balancer. So practically, what you have that Istio explain.io, what one would do is you would go to name.com or Namecheap or wherever you registered your domain. You would take that external IP address and you would say, hey, here's an A record, right? That points Istio explain.io to this IP address, right? And then gateway resource, you would say, for this host and for this port, yes, I want to listen to that, right? And virtual service defines how the traffic gets routed. But then if you want to expose the traffic through the ingress gateway, you are basically attaching a gateway to the virtual resource, right? And then the matching happens through the host names, right? And then once the actual route destination you have on line 11, for example, right? Once that destination is picked and the subset, you have subset defined, right? That's where the destination rule kicks in, right? And gets applied and matched, right? And it's saying, oh, so it's this host, it's this subset on this port. And then the destination rule is actually almost an equivalent of what are the clusters in Envoy configuration, clusters / endpoints, right? And then they know that, oh, if someone requests a host HTTP bin on subset V1 on port 80, I know that these are the endpoints that have those two labels set, right? That's the important thing here, right? Because when you're deploying things, your HTTP bin service doesn't have any Kubernetes service, doesn't have any mention of subsets or versions. It's generic, right? It only has like app : HTTP bin, whatever, right? Then you deploy the two deployments, V1 and V2, and set V1 and V2 labels, right? That way, Istio has the list of all those endpoints, but it also knows that those endpoints are, all of them are app HTTP bin, the labels, but some of them are version V1 and some of them are version V2, right? So with the destination rule, you're saying, this is how I want to slice it up. And then in the virtual service, you're saying, this is which subset I want to send the traffic to. Right?
Yeah.
And
So
the weight and everything. Yeah.
So as you said, so destination rule really is almost like telling the Envoy cluster what the Envoy cluster will look like. I think when you create a destination rule, I think those clusters get populated, even if there is no virtual service using that destination rule, right?
Yeah. There's always a cluster. There's always going to be a cluster called, I don't remember exactly, but there's always going to be a cluster called HTTP bin. But actually, there's going to be a cluster called HTTP bin pipe 80 port, right? And then when you do the subset, there's going to be another cluster named HTTP bin pipe V1 pipe port 80 and the list of endpoints, right? And then pipe V2 and the list of endpoints for it, right? So the configuration knows exactly, if the weight is whatever, 50-50, whatever it is, I have to go to V1. It knows to pick that specific cluster name with that hard-coded cluster name, I guess, right? And
I've got a question, and this is just more of a thought around it. So why wouldn't this be a single resource, a destination rule and the virtual service combined as one? And I'm asking this because in the simplest situation, we're just defining the routes to different versions. In the more complex pieces, we might be implementing TLS. But what are your thoughts around why we couldn't just combine them into a single resource?
I personally think that the subset stuff in the destination rule, logically, it makes sense to be there because it's applied at the cluster level in the Envoy configuration. However, operationally and practically, I think it should be in the virtual service, and the destination rule should be more of a lot of stuff in the destination rule is security related and like circuit breaker, right? And if you just think security stuff, right? Traffic security people don't necessarily care, right? They care about security settings, but not necessarily how many subsets you have and if your traffic split is 70-30, So I don't know, putting it into one resource, I think that would make the API huge. That's for one. But then also, I think it would be a little bit cumbersome to define the subsets. Maybe I don't know. I
think actually this is maybe one place where Istio was almost precognizant of the gateway API, right? So gateway API also was born to clearly separate the roles, right? So the cluster operator creates the gateway, and then the developers they take care, because developers know better, right? Know best, right? So they know best what kind of destination rules and what kind of labels and versions they are deploying. So I think it's also a way to separate roles. So a destination rule should exist to define the different versions of where to send traffic.
Yeah. I mean, it kind of makes sense. The only thing that doesn't make sense to me is the security, right, portion. Because you can imagine someone in like a production scenario, someone modifying a destination rule and then by mistake messing up some security things. It can happen, right? So just for that purpose, maybe it would make sense to keep it separate. But the whole idea, destination rule, everything that's on the destination, endpoint / clusters and Envoy, right? Things like traffic policy, right? Outlier, TLS settings, right? All those settings are on that side versus, I see the dilemma that they probably had when they were coming up with this, but it's like, no. All this is defined on the cluster endpoints level, which includes the actual subsets as well. So that's why they put it there, I guess.
But maybe you're right. I mean, DestinationRule is more like a endpoint side, like a server side in a way, and the VirtualService is the client side. But it's a rich API. I mean, there is a bunch of stuff in there that I never used, right? So, but it's an interesting object to also learn and reason about, right? So it's cool. It's cool. That's we will look into it. And I suggest everybody that is listening to also learn about DestinationRule. For most of the time, I only see like the very simple, you need a DestinationRule just to attach labels to the subset, and that's like a most common use. But indeed, you can do a bunch of stuff like a circuit breaker is.
Well,
done.
I think we'll have something about this tomorrow. The outlier.
Just so you know, I mean, so that's really what you need, all these, right? So to really get the traffic from outside in the cluster through the service and inside and to the Kubernetes services, you do need all these objects. So it's something that you have to do it, and it's, yes, you learn in and out. Likely during the exam, as we said yesterday, you can possibly. I mean, if it's like the other exams, you can go to Istio docs, istio.io latest/docs, search for whatever objects you want to create, and consult the truth, which the only truth, which is the API, which is this, right? So for example, when you want to,
one thing I want to add on the slide deck that you had on that specific slide, right? That's the scenario bringing traffic in from like through the gateway. Gateway is attached to the virtual service, but then virtual service, you would also use it internally, right? For internal services, right? So you could think of gateway, you're exposing your front end through the gateway. However, all the internal services are running internally, but you still might want to do traffic splitting or mirroring or whatever you want to do, or matching even, right, on those internal services. And in that case, you would just use virtual service. You don't need to attach a gateway to it necessarily, right? So gateway is whenever someone says we're trying to get the traffic inside our cluster, that should ring the bell. It's a gateway resource, right? You need that to bring the traffic in, right? When someone's talking about splitting traffic or matching on headers or matching on path or query parameters or whatever it is, that's virtual service. So virtual service does all the matching and also telling where the traffic should go. Traffic splitting, weight distribution, mirroring, and tomorrow we'll do injection faults and all those things. That's all virtual service, right?
Yeah.
So gateway is just saying this is the host and port combination, plus you can specify the TLS certs if you want to do the TLS termination at that point, right?
Yeah. So no layer 7 processing in the gateway resource, but just the layer 4, right?
I would, I mean, I'm not even thinking about it that way. I'm more like I'm thinking about this is the host this is the domain name that I have, and I want people to be able to open this domain name in the browser on port 80. And then if I attach that gateway to a virtual service, that's where I define where that thing should go, right?
All right. Okay. Moving on, because I mean, I don't know how many hours we have, like 2, right? So more or less like 2 or 1.
What do you mean 2 or 1?
What time we finished? Yesterday we went a bit far.
Oh, I think we should go. I think we should go longer on this one because it's a big topic, and we don't want to.
On the topic of gateway resource to configure egress traffic, right? So this is an interesting one, right? So, and let me pull up egress gateways. So how do you do this with the gateway resources, right? So We deploy because the demo profile as an egress gateway. The ServiceEntry we'll talk about it. Maybe we'll talk about more in detail. And then there is a gateway resource to control the egress gateway. So an important one possibly is in the exam because it does mention egress. So, and this is important. So basically it works like this. You are selecting, so the gateway has a selector. The gateway resource will select to which gateway it will attach itself to. In this case, the egress gateway. In my case, for example, you can do this. You can get the pods, and then you can look at the labels. So
Alessandro, could you make your terminal text a little bit larger?
Of course.
Thank you.
Yeah. One thing while you're doing that is, so the gateway resource, when we're talking about in terms of ingress and egress, it's the exact same resource. There's no difference, right? The only difference is in the label. That's the only thing, right?
In the selector, yeah. So
yeah. Yes, yeah. The label selector,
yeah. So this is what really matters. This Istio equal egress gateway. So because there is a label attached to this particular proxy, I mean, we just call it egress gateway, but it's for the point of view of Istio, just an envoy proxy running in a pod. And if you use this particular selector, that means that this gateway resource will be attached, or well, it will be used by this to control.
I would say configure. It's used to configure that specific instance of the gateway, of the envoy proxy. I'm gonna say
and this will again control what egress traffic to, for example, CNN.com will look like and will behave. And in this case, so you have a virtual service which will, let's say, so this virtual service is for the egress gateway again. So a virtual service also will be attached or will be used to configure specific traffic. So in this case, is traffic going out because it's attached to the egress gateway and that match this particular host will have this destination rule, and then the destination rule is what does it do this? So yes, so it will get traffic from edition.cnn.com. Let me get this straight. Destination host will send 100% of the traffic to edition.cnn.com when it comes for edition.cnn.com. Right?
Yeah, so the idea here is if you scroll to the virtual service, the way that I a little bit, yeah.
This one?
Yeah, so the way that I read this is and this is what happens in my brain, right? If I curl to edition.cnn.com from within the cluster, right? This virtual service comes into play, right? And it's saying, okay, so there's two gateways there. That's Istio Ingress Gateway. It's attached to it. So somehow we want to route traffic through it. That's my assumption. And there's the mesh one. And the mesh, it's a reserved gateway name that means applies to all the sidecars within the mesh, right? So if you don't specify, if that previous virtual service example that you had, when you don't specify any gateways, that mesh is implied, right? So that's always there, right? But now we're explicitly saying we want this virtual service to configure how the traffic gets routed for both of those things, right? And then what we do first is we say, okay, let's do a match, and we're matching on the gateway. And we're saying if this traffic is on the mesh gateway, meaning it's sent from a proxy within the cluster, right? So it's sent from within the cluster. That's how I see it, right? Then, so I'm in service A, and I'm trying to curl to edition.cnn.com, right? So this is where this is going to get invoked, right? It's saying, okay, in that case, I want the traffic to go to Istio egress gateway, Istio system service cluster local, which is the egress gateway, right? So it's basically saying route the traffic outside of this, route the traffic to that ingress gateway, right? And then the second match is basically saying, well, if the traffic is received, right, on this Istio egress gateway that's attached to it, right, then actually go to the edition.cnn.com, right?
Yeah.
So that's how it does. Like it first captures the traffic within the mesh, routes it to the egress gateway, and then it's saying, oh, now if it's there, when it's received there, go out to edition.cnn.com.
Yeah. So
but this one is not crazy complex, but it's more complex than your typical virtual service resources, right?
Yeah.
But that's how,
it is the only way, right? So otherwise, I mean, if without this first rule, the traffic will just flow out of the application.
It's not gonna work.
All the way to CNN.com.
Yeah, because we want to route it through the actual egress gateway, right?
Yes. So the first rule match the traffic coming out of the application pods with the envoy, and the second rule is just for the egress gateway.
Yes.
To actually send the traffic to wherever it is supposed to go.
Yes. And so you could theoretically have this in two separate virtual services if you wanted to, right? So
there's
no difference here.
Interesting.
One thing that I don't know if you're going to touch on it, but one thing that we should let me see if you want to talk about the actual traffic matching and how that happens in the virtual service, like matching in terms of like I want to when someone goes to peter.com/API, I want to route them to api.default.svc.cluster.local. But if someone goes to /UI, I want to route them to a completely different service, right? So these specific things are also interesting to talk about.
As always, you can go through this. So HTTP route rules, right? So this should be match, HTTP match request. And this can be pretty sophisticated, right? So you can match on headers, you can match on the
that one is on a header.
URI, on the scheme, of course. So HTTP, HTTPS, the method, of course. This is the classic when you want to prevent a specific method, like delete from. So you can match on a specific method, and the headers, very important. That's how we do also authorization, authentication, right? And the labels, right? So
source labels is an interesting one as well, where you can say if the traffic, you have service A and service B, and you can say I only want to route the traffic that comes from service A, right? And you can use not the properties of the request itself, because all the others that you talked about, like method, scheme, right? Those are part of the request. But the source label, you can actually specify and say app:/HTTP bin and app:/v2, right?
Yeah.
And that's how you can also match the traffic and then route it to any destination, internal, external, however you want, right?
Yeah. So it is aware of all the Kubernetes labels, right?
As well. Yeah.
I think traffic is tagged with the Kubernetes labels of the originating service.
Well, right? It's not. It's not the traffic per se. It's more of the configuration is aware of the labels, right? I think it's more that than the like the request itself,
But so this is actually the
Yeah, and there's the namespace one as well. I just noticed that one. I completely forgot about that one. There's from go a little bit lower. Oh no, it was there where you were. Just scroll a little bit higher.
Gateway,
query parameter. There you go. Source namespace. Right. So you can also say source namespace to say I want to match all the traffic that's coming from namespace blah, right? And then route it to some destination. But if it's coming from namespace XYZ, it's going to go to a different destination, right?
Indeed. Yeah.
Yeah. So there's a lot of ways that you can.
Well, in this way, you just selecting everything from that namespace is like having like a global label for all the workload in that namespace. So
yes, yeah, but it's using the namespace, right? Which I mean just tells you that you can like slice this any way that you want, more or less. Headers, query parameters, URI paths, methods, namespaces, workload labels, right? So you can be very, very specific how and where you want the traffic, how you want to capture the traffic, decide where it goes, right?
Yeah, and of course also the gateway, like in that this example, where was the example where you match?
Yeah, this guy. No, one more. This one. Yeah.
Yeah. So you match specific gateways, and then there's indeed this this gateways, special gateway called mesh, where you say
yeah, there you go. Yeah. So there's a lot of, there's a lot of ways that you can do this, and then for each of these, like if you would go to the, let's say the headers one, right? If you look at that, headers is I think probably one of the more popular ones that people do. Oh, this is not this, but matching, header matching. So I don't know what it's called, but no, not manipulation.
Not manipulation, but
it was there where you had it before.
I mean, this looks like this, right? So
yeah. So there's also a way for you to manipulate headers. Also,
this is a manipulation of the headers.
Yes, request and response headers, and you can like add them, you can set them, you can override them, or you can even remove them, right? So that's like you can think of this. Oh, for any example that comes to mind, for any traffic that's exiting my mesh, I want to strip all the headers, right? Or maybe internally you use some internal headers that you don't want to expose on the outside, right? Then you can use those. But this is the one. Yeah, this is the one that I. So I think all of these matching, all of the things that you can match on have these three ways of matching the actual values, right? So you can match the exact value, you can match a prefix, or you can do a regular expression. That's the one that I hate the most. But that one is the most like configurable, if you wish, right? But this just allows you to express things like, I want this header to be exactly this and nothing else. Or I want this header to start with dev underscore or whatever. Right? Or I want to be really flexible and I want a regular expression, right? So regular expression, maybe not on the headers, but on the URI path would be, match everything that's /product/ some number, right? Because you know that number is a product ID, for example, right? So it's just these three different ways of matching things that you can do, right?
So because, for example, here you're not saying either exact prefix or regex, so this will check for the presence of the my header.
Yeah, you can also do that. Yeah, you can also do that. Yeah.
Interesting. So this is where the magic happens, right? So we can say,
these are all
So
and this is like it's this is where the actual use cases and scenarios and practice, right? This is where what people want at some point, right? Mm-hmm. But this is very specific to what they want to do, right? It's like, I want to have a header called debug, and if it's set to true, I want to, I don't know, send it to my debug service, right? Or whatever, right? Or whatever you want to do. You're like, endless possibilities.
Yeah, based on the browser type or OS type.
Yeah, or user agent or whatever you want to do. Like you can say, oh, if it's curl, then I want to drop the connection. You can do that as well, right? You can say just send a direct response with a 404 or whatever, right? You can do that as well. So there's a lot of flexibility there.
All right. Well, so one more thing. So it's a complicated resource, right? The virtual service is the core, right? So there's a lot of options there. Not sure about what is going to happen in the exam, they're going to be the question, but definitely you need to be able to refer quickly to the documentation. And what you can do with virtual resource, you can manipulate. You can there's a matching part, right? So you match traffic, incoming traffic, headers, for example, like this, or the gateway that the request coming from. Something like that, or for example TCP port matching, and then do something about it, right? So route it to wherever it needs to go. So for example, in this case, this is like hard coded, right? So you are sending to traffic to a Kubernetes service, sort of hard coded, right? So you're not using subset, you're not using the Istio.
Yeah. But you could if you wanted to.
So
right?
in this case, for example, this product page may not be part of the mesh, maybe just a service in Kubernetes.
Yeah. It doesn't matter. It doesn't matter for this. One thing that the way that I like to read these resources when there's a match is HTTP match. I read this as if URI matches this prefix, then go to product page v1.
Yeah.
Otherwise, or for all other cases, or if it doesn't match, go to that other destination. And you'll notice that there's the second route is on the same level in the same column as match, right?
Yes.
So that means like that's an if statement, and that's like the else case, if you wish, for everything else that doesn't match that, because you can imagine having multiple match statements, right? Don't have to be one, it can be multiple. And one thing that I remembered, if you have multiple, they are processed sequentially, right? So they go in order. Now, if you remember earlier, I mentioned that you could split virtual services for the the same hosts into different files, right?
Yeah.
In that case, it's non-deterministic. So Istio will merge them together, the rules that you have, but it's not going to guarantee the order, right? So if you have some traffic, if you want to route some traffic, and you have to be very specific on how the rules need to be executed, right? Use one virtual service, right?
Yeah. So what you're saying is that because this is the default route of, as you say, right? So it's right under HTTP. So it means all traffic matching HTTP. It's not even matching any. It's not even attached to a specific gateway, or it's just matching everything basically in this namespace.
Yeah. It's just an example. Yeah.
So that's send all traffic there except when you match this and then you send it there. And then,
that one is specific. Yeah. That one is very specific. If the URI matches that specific thing, then go to that exact service over there, right? If it's not, but the thing that I was trying to say is the order matters, right? The order that this gets processed in. So Wilson was asking about canary releases. If you want to touch on that one a little bit.
Yes, canary deployments, right?
Mm-hmm.
So not part of the exam, I think, but still like
it's not explicitly called out. That doesn't mean that it's not in there, right?
So what is there to say about canary releases? Of course, like Istio gives you the primitives, gives you the tools to move traffic around, right? To different versions, subset, right, of the same service or different services, right? So, and but I don't think it doesn't do per se. It doesn't move the needle. It doesn't move the traffic automatically. So for this, there are things like Argo rollouts and Flagger that automatically scale those percentages, those traffic ratios between services. So I think Istio is very powerful because it gives you the tooling, but it doesn't have per se a logic to automatically scale traffic to one of the two, or roll back the traffic to previous version, right?
Yeah. There's no automatic logic, but there's a way to do this, right? And I think if you in one of the virtual services, I think just search for wait colon, and then you'll probably get an example.
Part of the,
there you go, right? So this is how you
route.
could do like canary release, right? You have V2, V1, and what Alessandro was saying, there's no automated way to do it. Is what you would do is for V2, you would probably set that weight to 1%, and then the other weight to 99, and then you would apply that resource, right? You would keep it running, right? You would have like a 1% to V2, the rest to V1. Observe, watch the metrics, watch the logs. If everything is good, you would update that same resource and say, well, now send 10% of traffic to this one and then 90 to V1. You would have to do it manually like that, right? But there is a way to do this, right?
Indeed. So yeah, Istio is not gonna move the knob for you. It gives you all the knobs, but something else has to do it. Normally, I mean, until Argo took over, of course, people were using Flagger, right? So Flagger.
Yeah, Flagger is another. Yeah, but it's the functionality is there, right? Like it's not just applied automatically, right? You could theoretically have like a bash script that checks for that. I'm not saying you should, but you could.
Yeah, but definitely look into so Argo or Flagger. So this is the magic, right? So there's a specific plugin for Argo rollout that will, you just point it to in this case, you are pointing to a virtual service, and then it will automatically increase the weight of the destination, right? So of the new incoming version or whatever, and will automatically scale down the previous one.
Well, Well, just to be clear with terminology, it's not gonna. Whenever someone says scale down and scale up, I always think the number of instances, but what you're probably meaning is the weight, right? It's
the weight,
increase, decrease the weight. Yeah. So this Argo is more like, the way that I see this is like a wrapper, right? That can allow you to automate this. And I think this is just a simple one, right? That waits for 10 minutes or something. And then every 10 minutes increases it for like weight of 5%, right? If you want to do it that way.
You see, it will just generate or like update the virtual service object by changing this weight automatically, like, and it will roll back if something goes wrong. It's all it's a very interesting thing. Argo rollouts is very popular, and it's the way to go. On the other hand, there's Flagger also very, very popular until not so long ago, and still around, and it can do exactly the same thing, like having where is the magic here? So there is there's a way. So
there's probably analysis, right, where it's, I think I haven't looked into it honestly, but I think it's able to actually check the metrics as well, right?
Yeah.
When you're doing rollouts, and then if there's failures, it's gonna like set the weights back or reverse the whatever he did. Hopefully this answers the question that was asked, and others, like whoever's others on the stream, people feel free to ask like any other questions that we can like answer or cover. Don't be shy.
So definitely, it's one use case for service mesh in general. But for Istio, you got these two options. At least the one we know. Of course, you can also be creative and write your own CI/CD pipeline that does that. But why reinventing the wheel when you have like great tools like Istio rollouts and Flagger to do the job, right? So. Let's move on. I need to leave in about 20 minutes because I have to go get my son, but I think we will cover the rest. So what is really missing now, of course, is ServiceEntry. Again, we have a great blog that you can look at about ServiceEntry. I mean, it's a blog meant for something else, but it's something that you can also see here how to define. So ServiceEntry is a way to define entities that live outside the cluster. For example, a virtual machine or a external database that you want to bring it inside, or you want your services within the mesh to be able to access this external endpoint, right? So, and it's a very interesting object again. Like can do a lot of stuff. In this case, for example, even defines the identities of the workload that is on the other side. But in general, like this is mostly used for things like ServiceEntry defining external databases, right, or virtual machines when you.
It's yeah. I would say it's just bringing any external non-mesh workloads and making it part of the mesh.
Yeah. So
yeah,
it's service discovery at its finest, right? So one of the use cases of service mesh is indeed achieving or getting a better service discovery, right? So you want those services within the mesh to be able to discover outside services. In this case, you can also do it with Facebook, for example. So in this case, is matching all those hosts. Location is an interesting one. So ServiceEntry location can be mesh internal or mesh external. You do this, for example, when a virtual machine is part of the mesh, but is not automatically discovered by Istio. So you define it as a manual entry and you put it as mesh internal, while everything else, like for example, the Facebook endpoint and so on, are mesh external services.
And I think if you scroll down to that section you were before, the difference is how the connection gets originated. If it's mesh internal, it's actually gonna initiate, like it's gonna originate or initiate. It's gonna do MTLS, right? If you set it to mesh external, it's not gonna do MTLS, right? So I think that's the big difference with external and internal here, right? Because with like GitHub API, you're not gonna do mutual TLS. With GitHub API, doesn't know about you, right? Unless you're GitHub, but
so it expects a proxy on the other side in a way, right? So
yeah, exactly. Yeah, exactly. So with the external, the MTLS is disabled, right? And the actual that's the first thing, and then the other thing is where if I roll back a little bit, so ServiceEntry allows you to make external services, APIs, databases, VM workloads, whatever, part of your mesh. And once you make them part of the mesh, you can also apply any Istio features to it, right? You can do all that traffic routing, you can do subsets, you can do like the outlier detection, whatever you want, inject failures, all those things, right? So the other thing that mesh internal, mesh external, the difference, one is the mutual TLS is disabled, and the other one is where the actual policy enforcement happens. With external, if you set it to mesh external, it's going to happen on the client side, because again, GitHub API is not going to evaluate your policy because it has no clue about it, right? So the policy is actually going to be evaluated on the client side. Whereas if you make it internal, we assume there's a sidecar on the other side. It's going to get the policy is going to get evaluated on the server side there, right?
Yeah, and one thing also about ServiceEntry, once you have a ServiceEntry, also means that you get the metrics about that external service, right? So for example, if you have this Wikipedia, you will see it in the Prometheus metrics spit out by the proxies. You will see the calls to this host, and we will see how many times this virtual services evidently is going to be it, right? So it's useful to have, especially when you have like external API you want to talk to and you want to know what's going on, what kind of traffic goes there. And there's an example here to redirect all the requests to that to those hosts to, for example, egress firewall or some sort of firewall. This could be like some destination in your network, like if you're on premise and you need to do to send the traffic all through some sort of corporate firewall. That's how you do it, and it matches only, of course, this host. You can also use a wildcard here and match all the hosts if you are so inclined, and that will send all traffic to the outside. Can you do a ServiceEntry with wildcard like this, right? Just
yeah, you have it there.
Yeah,
the
right?
second line. Yeah. So ServiceEntry is basically bringing external stuff in, and then that scenario that you were talking about there on the virtual service. One thing that you could let me think about what would be a realistic scenario, right? You could say, let's say Wikipedia, right? All your services are calling out to Wikipedia, external Wikipedia, but what you want to do is, instead of calling to external Wikipedia, you have an internal API that does the same, and you want to route the traffic there. But you don't want to go and change all of your services, for example, right?
Yeah.
So you could do it that way.
So you do it centrally with one object, or a few objects. You are redirecting all traffic to that match that host.
Yeah. You're basically making that, and that Wikipedia.org or whatever it was, it could be like you could come up with something else. It doesn't matter, right? That could be PeterJ.com or whatever it is. Even though if it doesn't exist, it doesn't matter, right?
Yeah.
Because you can then route it to wherever you want, theoretically, right? And you can do like virtual IPs as well if you want to. So yeah, it's a lot of flexibility, but in most cases it is used for, well, not in most cases, I'll say the most common place where you would see the ServiceEntry is when you're trying to bring the VM workloads, right, into the cluster. Or when you have multi-cluster scenarios, right, and you want to set up a global host name, right? If you think about scenario having 3 clusters, multi-cluster scenario, you have 3 clusters. Each cluster has a service called Hello World, right, running in 3 clusters. But in cluster 1, the host name is hello world svc.cluster1.local, right? Cluster 2, cluster 3.local, right? But how do you route traffic or split traffic, let's say, across multiple clusters, right? You can't use HTTP bin svc.cluster.local, right? So what ServiceEntry allows you to do is you could say, well, I'm just going to create a ServiceEntry with a host name of helloworld.global.com or whatever. And then you're basically saying, whenever someone calls that helloworld.global.com, I'm going to have a virtual service that's going to route the traffic somehow across those 3 instances in multiple clusters or wherever they might be, right? So that's another pretty common case that one can do.
And you use like this, right? So mesh internal and
it would be global, whatever. And then, resolution doesn't, I don't know. You probably wouldn't set it to static because then you have to provide like IP addresses. You don't have those, right? But you would probably do it at that point if you're, but that might be topic for Friday maybe, or like a mention on Friday. You could do like a workload entry selector, right? And then use workload entries to represent those different things. And
we like this. Yeah, so workload entry is another object.
Yeah, they're like this one, right? This one has like a there you go, front end my company mesh, right? So it's across the board. That address 2447, it's just a made up address, doesn't mean anything, right? And workload selector is just pointing to that, and this one involves east-west gateways as well, right? So we can route between the meshes. And actually, the second thing in this blog post is talking about the scenario that I mentioned, the locality, right? This is where you can then label your node. I think you're labeling the nodes. I don't remember exactly anymore, right? And
these are probably labels on nodes, right? So
yeah, and then you can say, oh, this is my east, this is my west, and then you can route the traffic based on that as well.
Yeah,
right?
and this is, I don't know if this is in the exam, but the IstioCTL PC is the proxy config, right? So it shows down to the Envoy proxy configuration. In this case, you are actually asking, what is this cluster look like? How does this cluster look like? And indeed, there's this locality associated with the class, with these IP addresses, really. That works this way. I think this 34168, this one, right? So there's it's probably a VM, right? So because it's got this fixed IP address, and then you can select that this is in a specific region, and then you can make a decision based on the locality of the cluster.
And a pop quiz here. Does anyone know which resource is used to configure the locality? We didn't mention it exactly, but we did mention one.
The destination rule?
Yes, it's destination rule. And the reason for it is because that configuration ends up being on the cluster in the Envoy configuration, right? So that's a little bit of a trick question, maybe. I don't know.
Yeah, so it's part of the API. I mean, this is like the Kubernetes object, right? So I always go to locality LB setting, right? So, so this, we also have like the failover distribute and failover priority, right? So that's
there's a lot of. I personally don't think this is in the exam because it's fair. Maybe it's part of the advanced topics, but I don't. It's a fairly out there thing. What do we have left? So we have the define traffic policies using destination rule, right? That's the next one.
How would you? What do you think is this? Because I also had a bit of a trouble understanding what is traffic policy using destination rule. Like this, like locality, you think? Or
no. So I think the traffic policy is more of a. So we talked about subsets, right? As part of. I'm assuming that's part of the whole controlling network traffic flows within a service mesh. I'm assuming it falls under there, but the traffic policy would more be about. Like which load balancer algorithm you want to use. Since destination rules is applied on endpoints, right? And you might have thousands of them or hundreds of them, right? You can pick which load balancing algorithm you want to use. And then what is the connection pool settings? And then outlier detection, we'll talk about it tomorrow as part of the injection resiliency or whatever we're calling it, right? And then the TLS settings, right? Those are the other settings that where you could explicitly say, oh, I want to use mutual TLS with this destination using these certificates and this private key, for example, right?
Yeah. Or maybe in the exam it's simply configure destination rule with round robin, and then you just have to do this.
Could be, yeah. Could be. But that's what I consider like traffic policy. And even if you go in the documentation, that's what you get under traffic policy, right?
Yeah.
And then setting traffic policies.
This.
Yes. Well, client TLS settings, this one part of it, but you can also set it on like port level traffic, right? So you can specify a specific port and then set the traffic policy for that port only, right? So you can say, I think there's an example if you look for port level settings.
This one?
Yeah, there might be an example somewhere. If you search for port level settings on, might be on this page, I think. Yeah, there you go. Right.
Okay.
Yeah,
So
you can
different ports gets different load balancer.
treatment. Yeah. You can set like different. You can define a global traffic policy for that ratings prod, whatever, and then you can say, but on port 80, I want to do least request algorithm, or I want to do like round robin or whatever it is. Those different things. But then you can also do things like, I want to use this TLS certificate for this port and another one for this port, or I want to disable it completely for a third port, right? So there's a lot of flexibility.
Object or key can be top level under spec or can be under port level settings.
If you want to do it per port or apply it to like specifically for a port, right?
I think it's the TLS stuff is interesting because, of course, like maybe it's a service that lives outside and is not under Envoy and it's not under Istio control. So you have to.
Yeah, if you want. Yeah. Like an example, I think this one is configuring that exact scenario that I wanted to mention is you have an external, in this case, it's a database, right? I'm assuming that you own. It's not part of the cluster. You own that, but you still want to do mutual TLS, right? So you control both endpoints. That's where you would go and say, because this is an external one, I want to specify the mutual TLS mode and then specify the certificates you want to use to do mutual authentication with that external service, right? If you want to, or internal, however you want to do it, right?
I would say also, because here, like they specify like files, right? But those should exist on the originating Envoy proxy.
File
system, right? So
you have to
find a way to mount this.
Yes, yeah. That's more of a when you would go and like, you're not gonna do this. I hope people who don't know what they're doing, they're not doing this yet.
No, it's a bit more.
If you want to do mutual TLS, you should probably know how to mount stuff into the pods as well and deploy
rotate, right? So
yeah.
Maybe this certificate expire and so on. So
yeah.
I really need to go in 5 minutes. I just want to touch traffic mirroring, of course. So this is interesting because it's part of the Istio documentation, right? So it's part of the, of course, this. So this is this is the Gateway API. Of course, we haven't talked about it, but there's a way to do it in Gateway API, and it's interesting because it's an Envoy filter, really. And in Istio API, you use a VirtualService where you just put under route, HTTP route object, you put mirror. Yeah. It does the same thing. I mean, it calls the Envoy mirror filter. I actually put the link here, which is this one. So eventually all boils down to Envoy filters, right? So, and this does this fire and forget. So, and that's why I put the Javelin there. So what does it mean, fire and forget? So all the traffic that is sent to the mirror, the client Envoy proxy is not going to wait for a response. It's going to wait for a response for the main traffic, but it's not going to wait for a response coming from the mirrored destination, right? So this is it's interesting because you can have a subset, like a new version coming up of the application, or maybe for auditing or compliance, you need to register all the calls to your services. So with this simple virtual service flag or API, you can just send all traffic. Also, you can send less than
more or less,
100% to a different subset, and that's it. So that's
yeah. I think you mentioned a couple of scenarios. One thing that it's almost like Canary, right? You can, if you want to compare it to Canary, the only difference is that no actual, if you think you have end users, right? You have end users accessing your services. No actual end user is going to get affected when you use mirroring. Whereas when you do Canary, the percentage of the users that they're going to go to that other version, right, will actually see that other traffic, right? They're going to get affected, if that makes sense.
Or maybe you can see it this way, that when you use Canary, the sum of the request has to be 100%. In this case, will be 200%, right? So it's just basically sending load balancing, mirroring every request, but the sum total is more than the original, right?
Yeah. You can, but I'm always thinking like practically, right? Practically, if you do Canary and your V2 version has a bug, your users will be affected, right? If you do mirroring, no one's going to get affected.
No, because there's no response. I mean, maybe the service will send a response, but it will just be dropped by the client.
Service can do whatever they want to do afterwards, right? But it's not going to, the response back from the service is not going to go anywhere. One thing to be careful about is if you want to do mirroring at some point is make sure you're not doing things like, let's say you want to mirror, you have a service that adds a user to, adds an entry to a database, right? Let's put it that way, right? And then you bring up the other service that you want to mirror the traffic to, right? You don't want to mirror the traffic to that service and have that service actually make an entry into the database, because then you're screwing yourself up, right? So make sure that, make sure you think through the scenario, what's going to happen, and you're not doing things like that, right? Like writing to a day. There's an idempotent. Make sure that those calls are idempotent and nothing actually changes. I think that's the right word, right? So it's not going to affect anything when you mirror, right? Canary is different, right? Because the response is going to get back to the end user or someone, right? But in this case, it's not gonna, it's gonna end up in digital heaven somewhere, right?
That's true. Databases are tricky. State is always it's a minefield, so do it carefully. But this is a very powerful feature. I think it's because you get real data, right? So not some mock. No, these are real requests from real users being duplicated to another service, which can analyze them, or maybe for performance tests. Is my new version able to withstand the load that the current production is under, right? So this could be...
you can do that, because all the, like, you will still gather the metrics, right? You'll still gather everything. I think the metrics will be marked with there's going to be a word called like -shadow or something, so you're going to know that the metrics are actually coming from the mirrored version there. So,
guys, I'm so sorry, but my son is waiting for me to pick him up.
Okay, I mean, well, Marino, I think we should stay for another 5 minutes.
Sure.
Have any questions? But
All right. Thanks, Alessandro.
Talk tomorrow. Thank you.
See you. Bye.
So I think just to set the stage for tomorrow, because tomorrow we're going to cover a bunch of resiliency related capabilities in Service Mesh or in Istio. Let's actually spend some time seeing a virtual service and DestinationRule in action, and that'll set us up for testing out like just the resiliency capabilities altogether. So what I think I'll probably do tomorrow at the start is we'll jump right into the demo, take a quick break, and break in the sense of go back to the slides and then review some of the concepts around fault injection, tolerance, and resiliency, because there are topics around circuit breaking that we have to cover to understand how an app continues to function when a service fails in path. And so it's always great to really see that in action, but I've got some diagrams that I want to put together so we can better understand it. But from today's session, how did you all feel? Did you have any questions? Anything that we can answer? I know it's a pretty deep session because there's just a lot of traffic management capabilities and resources and moving parts.
Yeah. Is anybody out there? I think there are people out there, but they're awfully quiet today. But don't be shy. Feel free to ask the question. It is, as Marino said, it is a big topic, and there's a lot of there's a lot of like features we could go in, right? But it's guessing at our end, right? We cannot know what's in the certification if we talk about that. But definitely like knowing how the traffic comes into your cluster with the gateway, the matching on the host names, right? Attaching the gateways to the virtual service, then doing the matching in the virtual service, and then applying the destination rules at the end to do that. I think that's important to understand, right? But yeah, going through some demos tomorrow might make sense in the beginning, just to solidify the whatever we talked about today, and then we can jump into the resiliency and circuit breakers, which are kind of in a way like traffic management. It's separated out. All right. I don't know. I don't see any questions. I hope this was useful. Let us know. Let us know on Twitter or wherever you can find us. We're not hiding. You should be able to find us, and we'll see you all tomorrow. Same time, same place.
Yep. See you all tomorrow. Take care, everyone. Bye.
Bye.